All right, here we go as we wrap up Chapter 8 with a study of probability this week. The probability of an event. Well, first of all, what's an event? An event is a subset of some possible results of an experiment. An experiment is something that happens. It's a happening. And an outcomes are possible results. And the sample space for the experiment is the set of all possible results. And an event, which is what we're mostly going to be concentrating on, is a subset. And the probability of an event, well, that's how likely it is that that event occurred, given everything else that we have in the description of the experiment. So first of all, here's some math before we look at an example, here's some math behind it. The probability of an event mathematically, or P of E, is going to be the number of ways the event can occur divided by the total number of outcomes in the sample space, provided the outcomes are equally likely. So because of that fact, the smallest that any probability can be is 0. If the event can't happen at all, those are called impossible events. And the biggest an event probability could possibly be is 1. If it's a sure thing, those are called certain events or certainties. So here's an example. The experiment is we're going to toss a fair coin 3 times. Now, what would I mean by a fair coin? Well, that's a coin that's either heads or tails, and it has an equal chance of coming up heads or tails. And so here's the sample space for that experiment. These are all the possible outcomes that could occur if we toss a coin 3 times. And if you think about the counting that we just did, the first time you toss the coin, there are 2 possible outcomes. The second time you toss it, there are 2 possible outcomes. And the third time you toss it, there are 2 possible outcomes. So the total number of outcomes, if we were to count them, is just 2 to the third, or 8. And there they are. I've listed the sample space. So what if an event is get exactly 2 tails for this experiment of tossing the fair coin 3 times? So the probability of getting 2 tails, well, that would be the number of ways we could get 2 tails divided by the total number of ways we can toss a coin 3 times. Well, we know the denominator is going to be 8 because we can count the numbers in the sample space. And if we look through the sample space, we could just circle. Let's see, here's a way we get 2 tails, and here's a way we get 2 tails, and here's a way we get 2 tails. Exactly 2 tails, so the probability is the fraction 3/8. 3 chances out of 8. Here's another example. What's the probability that from a standard deck of 52 playing cards, we draw a single card and we get a face card? Well, the number of face cards is 12, because the face cards are kings, queens, and jacks, and there are 4 suits, so that's 12 possible face cards. And the total number of cards is 52, so that's 3 chances out of 13 that we're going to get a face card if we draw a single card from a deck of 52. That's about a 23% chance. Sometimes probabilities are represented as decimals and in turn as percentages. Sometimes. You don't have to. Here's another example. We're going to roll a pair of 6-sided dice. What's the probability that we'll get a number less than 5 on either die? Well, here's the sample space for that experiment. I just listed all the possibilities. I restrict myself to those events in the sample space that have either a 1, 2, 3, 4, or 5 in them. And so you can see the probability is going to be 35 out of 36. So that's quite likely that if I roll 2 dice, I'm going to have a number less than 5 on either die. Here's a map of the United States. The numbers of colleges and universities in various regions in 2012 are listed. We're going to select one institution at random. Maybe we have all of them written on slips of paper, and we're going to throw the slips of paper in a hat and mix them up. Or maybe we're just going to take a Barron's book and flip the pages and open it to a random page and point to something. What's the probability that the institution will be in one of the 3 southern regions? Well, we can figure out how many southern regions there are. The West-South has 447 institutions. The East-South has 308 institutions. And the South Atlantic has 876 institutions. So if we add all those up, that turns into 1,631 institutions. So the probability, I'm just going to say S for South, the probability that the region, the randomly selected institution is in the southern region is 1631 out of 4706. Now, where did I get 4706 from? Well, if you add up all those colleges and universities, that's what you get. You can check me out on that if you want. And this is about 0.347. So about a 35% chance that a randomly selected institution of higher education would be from the southern region. What about the probability that the randomly selected institution is in the Pacific region? Well, you can pause the video if you want to think about it. But the probability that we're in the Pacific region, it's pretty easy. It's going to be 640 out of 4706. Or about a 0.136 probability. Only about a 14% chance of that happening.